Good afternoon. Thank you so much for joining us on this International Firestop Council webinar, Deceptively Dangerous Spotting Firestop Installation Failures. We're going to get right into it today. This is a 1-hour webinar. If we go a little bit over for questions and answers, that's fine. This course has been approved for ICC CEU credits and for AIA credits as well for continuing education. Today's presenter is Brenton Johnson. He'll be presenting and answering your questions. If you have questions, you can insert them into the questions box and we'll answer those at the end. But I'm going to turn over to Brent right now and let him get started so he has all the time that he needs. Brent, thanks for doing this for us and for presenting today. We appreciate that. I'm going to turn it over to you.
Yeah, thank you, Aaron, and thank you to the International Firestop Council. We do have a lot to cover in a short amount of time today. And just as a couple quick housekeeping items, I think Aaron mentioned this is the ICC course number on the screen right now. Just want to make sure everyone gets a chance to write that down if they do need it. And we will be probably using about the full hour. I believe there is a way to ask questions, Aaron, right, in the chat. Potentially, maybe we'll take a look at those if we get time at the end. So got to power through a good amount today. And if we do have questions, I'll do my best at the end to go back and look at those. So thank you for your time. Just a quick overview as we get moving forward. This is copyrighted material from the International Firestop Council and Firewise Consultants. An overview of today's training class is really big picture. Look, you might be new to the industry, you might be very seasoned. You might be an inspector, an installer, a design professional, an AHJ, a lot of different roles attend a class like this. But the big picture discussion we want to focus on today is most of us have seen Firestop. Most of us are aware of Firestop and what's going on. But the common challenges, I think, as someone like myself who's been in the industry for 20 years, and maybe yourself as well, is that many times we focus on not as much as we need to, or different individuals we're learning and having to understand what to look for and what questions to ask and hopefully help me do my job more efficiently. You know, that can be a challenging task, especially if we're learning the process or, you know, handling a lot of tasks. So what we wanted to focus on this webinar today was a couple big picture items. One, you know, aesthetics. We like to focus on aesthetics, but there's a lot more than meets the eye when I look at a Firestop installation. If I'm inspecting or installing or just auditing it, you know, looking at it is very helpful, but isn't there a lot more that goes into the overall listing and code compliance? And what is that? What questions could we ask? What tricks or tips could I maybe better understand to help me, you know, I look or audit Firestops as they're installed or post installation, you know, what we're really looking for. And throughout this class, we're going to try to use a lot of photos to kind of stop and talk about something. Now, these photos, you know, we all might not agree on certain things, which is totally understandable. And some of these photos might not match your exact construction that you're dealing with today or often. But hopefully, big picture, you get the concept of, you know, when we're looking at something or inspecting something or installing it, to make sure we take the time out and take the extra couple minutes to find another document or read through this document to make sure we're not assuming that what we've seen for 30 years has always been correct. Things are always changing in our industry. Some people might not know in Firestop, the code we know changes, but also test standards change, which means products also change. And what we have to do to get the listed systems that you install and inspect to might always be changing. So you might have done something last year or a couple years ago and move on a new job, do the same thing, but it might have changed. So try not to assume what we always have done is correct. And then overall, you know, what documents are out there and how we can utilize them to our advantage. So in an hour class, you're not going to become an expert in Firestop or inspections or any of that kind of stuff. I want to note as the bottom of the screen says, this webinar is not going into how to do the inspections. The IFC offers a full training program on that process. So we are not talking about ASTM E2174 or E2393 specifics today, but the information that we do talk about hopefully can help you perform your inspections. If you're QC, you know, performing those audits, and AHJ, same process, or if you're an installer or design professional, you know, the topics are all the same. We're all playing in the same pool. We all use the same documents. We all have the same, you know, challenges. So let's kind of go through that together. So one of the biggest things, if you've seen an IFC training before or something like this, that I think the industry always tries to promote and remind everybody, even if you're seasoned, The fire stopping products we're going to talk about today do not hold a rating themselves. You're going to see that the code doesn't talk about a product. It talks about a listing or a listed system, right? In a test standard where we have to install materials into barriers that are already rated or have their own rating. And we're helping to restore the hourly rating of that breach or penetration or joint with a product per a test standard to obtain a listing. So don't assume again that all products are going to be rated for up to 4 hours for all conditions on our project, right? I think many of us know it comes down to the specific listed system and the parameters of the installation that is within that. And what I like to point at the bottom of the screen is a screenshot from a listed system. Again, a little disclaimer, we're not going into how to read ULs or Intertech listings today. There's, again, separate trainings for that. But what I want to point out and remind people is that the barrier itself that we're working with, a wall or a floor or different elements like that, right? Those have their own section of code, their own potential inspection, their own potential installer, their own potential listing. So there's a lot of other parameters that build that assembly, right? That we as a Firestop installer, designer, or inspector might not have anything to do with. But for us to do our job properly, we need to verify that that assembly is built the same way the tolerances in my fire stopping listing are called out. Meaning, I have to remind myself when doing this work that the most restrictive design is going to play. So a listing at the bottom of the screen could say, look, you could use hundreds of these different wall types, please. Good luck, lots of options. But I could read the fine print and see that I can only have a stud that's 4 inches deep, or I have to have an angular space around my penetration of a half of an inch or less. So just because the wall assembly might be able to be built in a smaller stud depth, or my opening could be obviously cut larger in other listings, doesn't mean this exact document that was handed to me to do my inspection is compliant. So what I'm trying to say is products do not hold the rating, hope we know that. And also we might need to back up depending on our role and look at the overall picture and understand who's inspecting the barrier, who's building the barrier. Are they looking at all the documents that I am? Are they all working together? Because we can't just put Firestop in any assembly and assume that it's going to be rated. So I walked the job just this week, very large healthcare facility under construction. And I took these pictures and, we're not going to dive too far into it, but I wanted to point out when I said aesthetics earlier, one, I think many of us know just because it's red doesn't mean it's Firestop or it's going to be compliant or it's right. There's all different colors of Firestop that we're going to see today. It doesn't have to be red. But a common condition where we have some low voltage sleeves, and we're not going to get into the other challenges we might see here in this photo, but we're going to focus just on the Firestop sealant. Hey, professional Firestop contractors installed. There's lots of large projects. Very clean installation looking at this when we're walking the project. Our job was not the inspector in this case. We were helping on solving problems, but we then were walking the job further and saw this one where someone removed one of those sleeves. And take a look at that there. I have 1 layer of drywall and then 2 layers of drywall, 2-hour wall. And you can see in this photo, the majority, without measuring, the Firestop appears that it was all applied on the outside of the wall. And it almost looks like the entire 5/8 right here have no material recessed into it. Now I have a picture looking the other way to show that it's basically the same all the way around the opening. What people might call out and say, look, listed systems allow tolerance. They allow angular space differences, right? Where it could be a minimum of 0 point contact to max 1 inch. But this intumescent fire stopping sealant will expand in a fire most likely at different ratios depending on the products. So it's manufactured, it's engineered to be able to expand and seal off gas, which is great. But in this case, the contractor used this listed system. There's actually a label on the wall here pointing to it, and it actually calls out point contact. I just want to define that and remind people that there are definitions out there what that means. The industry standard definition of point contact means it touches one side of the barrier. So the pipe could have been touching, sure, right here, and that's a good point contact installation. But all the way around, the listing should say continuous point contact, and that was not the one selected. So what I wanted to point out here, just maybe I'm wrong, maybe I'm right, I didn't do the inspection, but just visually, man, that's a clean installation, looks good, right? But if I wasn't there to witness the installation or perform a destructive test to verify that 5/8 of that intumescent sealant got recessed into the angular space flush with the face of wall per this listed system that was selected by the installing contractor, How do I know it was compliant? So let's not overlook the aesthetics is really the message there. Let's look beyond the aesthetics, right? And what's behind these materials, because there's a lot of material there that in a fire it's just going to expand out and fall off the wall. It's intumescent, it expands. What doesn't do us any good on the wall, the focus of many of these materials, as we're going to learn, is into the opening or the annular space. And for those who don't know, I apologize, annular space is going to be the distance from the outside diameter of the pipe to the inside diameter of the wall or floor that we're penetrating. So basically where my fire stop is going to be installed. How big is that gap? So overall, good picture to kind of back up and make sure we're thinking big picture for the start here is here's an example of a fire test of penetrations. And what I want to remind people of, this is exactly as it comes off the furnace after 2 hours. This is showing the fire side. Obviously, here's the furnace. Everything's glowing hot, right? But take a look at the drywall. The drywall is pretty much cracking, falling off. Some of it even fell off in the furnace itself. There might be voids. This looks like the whole, piece of drywall fell off. The pipes are red hot. You can see some of that intumescent material right there is actually expanded a bit inside the furnace. But what we like to point out here is on a wall assembly, a framed wall assembly, like metal studs or wood studs, the fire side of that assembly is sacrificial. So we know in a fire that each layer of drywall lasts about 20 or 30 minutes, a 5/8 type X. So we know that it's going to potentially burn out or fail. That's why we have to inspect and install both sides of an assembly, right? And the majority of the fire stopping listings that we deal with, we fire stop both sides of a penetration. Now there are unique, options out there, but commonly that's what we do because this is the example showing that the drywall, the fire stop, all this, is going to give way after, 20 or 30 minutes per layer. But what I want to remind people of on top of that is that we also have to go through what's called a host stream test. So a host stream test, let's see if it's going to work for me here. A little noisy. But after the fire test is done, we're also verifying that the materials do not dislodge or loosen from large amounts of pressure, right, that goes on the fire. So we have to verify that not only the fire stop, but also the assembly we're working with all stays in place. And as you can see in this video, different tests from what I was showing you, but I see a lot of daylight. Daylight's not a good thing when we're looking at this, right? So the wall itself was what I'm trying to show could completely fail. And that goes back to my original point. Let's not overlook the barrier we're working with because the fire stops have to work with that code compliant barrier, right? And if something goes wrong with the barrier, there goes my fire stop, right? So we fail the test potentially just because even the barrier doesn't work. Or if my material gets dislodged or loosened from the fire, obviously, or after the fire with these host stream tests, then I also fail. So in this case, we tested a very large annular space. And the material you can see also dislodged and came out after the fire test. It stayed in place during the fire test. You didn't see a photo of that. But this is a bad failure where everything basically blew out. So I just want to remind people that it's not just the product, right? It's all the parameters built together that goes into this. And the tests that we perform to get you those listings are very, very challenging. But that is the lifeblood of what we're doing today. So if we're not inspecting or installing or designing or doing our job without this document, I have to continue to preach that we got to have our listed systems approved, verified, and with us to perform our installations inspections because it's our recipe, as people have said. This is going to go through and tell us how to build it, show the AHJ that it's code compliant and meets a test standard that is listed in Chapter 7 of the building code and has ratings, again, that are listed in the building code to show us that we're code compliant. On top of that, we do get questions that are asked to say, hey, is any section of this more important than the other? Can I just, skip through the wall assembly? That was someone else's inspection. That wasn't me. The fireproofing, that was somebody else. Unfortunately, the response is going to be that each section of this listed system is equal. So we need to check all these boxes off, meaning if I'm not doing the fireproofing, the decking, the framing, the fire, drywall, all those different parameters, we have to verify and make sure they match up with the listed system. A change or an update that I wanted to point out in the building code, we're not diving that too much. Again, there's other trainings to understand the code, but we do want to touch on the 2018 IBC now actually calls out installation instructions along with listed systems. So kind of an add, and it's something that we've talked about. Maybe you've heard it before from the International Firestop Council, but we're really pushing hard to make sure you have your listed system with us approved, but also remember, The code's also calling out installation instructions. Why that's important is the listed system might tell us it meets the code, it gives us these ratings, it can go in these barriers and these products, right? But it might not tell us how to cut the material, how to install the material, how to compress it. All these other parameters might be found in the installation instructions. So again, adding to our recipe that we need with us, the code is now saying, please also have your installation instructions along with your listing before we perform this work. So again, let's take an extra minute, make sure we have that with us. On top of that, if you're performing Firestop special inspections, this screenshot here is maybe a little confusing, a lot of words right now, but what we're trying to point out is that you may be asked, it's in the standard, just so you know, so you should, verify the storage and handling of the materials that are being installed or were installed. So in the product data sheet, we're going to find a lot of items. You're going to find things like, where do I have to store it? What temperatures? What temperature can I install the materials in? How long does it take to cure? What's the shelf life of the material? Can I paint the material? Is it, how do I repair the material if there was damage? Or I have to, do a destructive test and things like that. So I just wanted to point out that product data sheets, again, should be in submittals, just like installation instructions and listings. But the biggest challenge I've seen as an outsider and seeing people do inspections and helping that process is getting you the right information. Our job, if you're an inspector, is to not dictate and tell what to do. We're observing and reporting, right? I showed up. Okay, here's my inspection report. Did you include a location, a map, a listed system, the product data sheet, all these different things that we're asking for, or we're all just standing there pointing fingers like, I think it's this UL, I got this fire cock I always use, and I'm gonna smack it in that hole like now because I've done 10,000 of them already like this, and look how pretty they look, right? That could be some of the common challenges we have as the industry. So our recommendation is, let's not just look at the product and go like we all might need to do, and let's make sure we have the appropriate documents for us to perform our inspections. A little tip and trick, if you have questions, again, we don't dive into it today. There are additional trainings for this, but UL has some guides. I'm mentioning some different things and some terminology and some measurements and things like that today. If you aren't familiar with them, please look up UL guides XHEZ, XHBN, and XHDG. These are the guides for through penetrations, joints, and perimeter fire containment. The IFC has them on firestop.org. There's a link to them as well as to UL's on UL's website directly within the reading literature of the IFC's website. So in there's a lot of great information. We're not going to cover it today in depth, but I highly recommend if you do any scope of work and have questions or want to learn more or understand what we talked about today, a lot of information is actually found in those guides. UL has published multiple documents to try to help aid these questions. So let's try to use them as an industry. One that stands out there though is XHHW. I didn't cover that yet, but shrinkage. Not all fire stopping materials shrink we're going to talk about today, but some do. So, if you think you've got a tube of fire caulk, you cut it, some water might come out, right? And then we squirt some goop in a hole and it looks kind of wet when you touch it and you come back a week later and, hey, there's a crack right there. What the heck happened around that pipe, right? Well, many of these materials might even be water-based materials that the water would evaporate over time, right? So that's totally normal and acceptable and standard, but there is a shrinkage value within these materials. So to calculate that shrinkage value, if you're doing destructive testing or you just want to understand what materials might shrink, you can look up XHHW on the UL website, or maybe the manufacturer can provide you that information. I took a screenshot of, I went to UL Product IQ. If you're not familiar with that, you can definitely sign up for a free account. You can see my name's here, so you can sign on in. I can even just type in at the header XHHW. There's even a drop-down tab. I can pick my manufacturer of products I'm looking for, and then I can grab, hey, 3M, look, IC15, which is this yellow stuff here, it average shrinkage volume 26.64%. So if I installed it at 1 inch and I came back 2 weeks later and it's 3/4 of an inch, the way I read that is I'm still in compliance. And the note there, if you don't know, again, the UL documents will help explain this. The UL listing, if it does not say if it's wet or dry, that is the wet thickness. So if the listed system said 1 inch thick of IC15, Firestop sealant, that would be the wet thickness, because there's no way that we could have verified that, once installed, as you as an inspector or installer too, right? We usually don't get to see the back of the wall all the time. So there are ways that shrinkage can be calculated. What I like to point out, though, for those of us who do this work, is this is a test standard that the shrinkage is evaluated to, and it's at 73 degrees, temperature in a controlled environment at 50 degrees, humidity over the life of that curing process. We might live in San Diego, California, where the weather is pretty darn close to this, but it's not 73 degrees 24 hours of the day. So where you live creates a large variable here. And I will call this our first gray area of the day, that if you perform Firestop special inspections or installations of fire stopping materials that cure and have shrinkage values, it's hard to get an exact number. So this is a good discussion to have with your manufacturer ahead of time and the AHJ to say, look, we have ballpark numbers here. What tolerances are we looking for when I'm doing destructive testing? All I'm trying to point out is it might look nice and clean on the face like this. I pull it out, you can see my picture on the right. There could be thicknesses larger, thinner. What was the range that was acceptable? How do I find that information? How do I get that approved? Because the Firestop listing was the wet thickness. As a reminder, if you perform destructive tests, we're not getting into that today. I'm just showing you some pictures. The IFC does have recommended guidelines on their website, firestop.org, to go through their recommendations of how to perform these destructive examinations and inspections of fire stops. So covered a good amount of backstory there. Good big picture items, hopefully. Some documents if you haven't seen them before. Now I want to get into the products. Today we're going to start with fire resistant joints and perimeter fire containment. There can be some of the most confusing types of assemblies. They might not have as many product types as we see in penetrations, but overall, there's some items we want to make sure we cover, what to look for, what to watch out for, and what's behind the red spray in this photo, right? What are we focusing on? So as an industry, the industry continues to evolve. There's standard sprays that we'll call them Firestop elastomeric sprays and sealants. Very commonly seen. You might have seen these before. They can come in all different colors. It doesn't have to be red again. There's also intumescent gaskets of different types, tapes and foam gaskets and vinyl and a lot of different types of pre-manufactured products that are in the industry, and that continues to evolve. So what I wanted to point out in this photo is many of those preformed products might be intumescent, like you see there. You kind of see how it kind of flakes out as it gets hot and kind of expands at different ratios. The standard sprays and sealants that you see in fire resistant joints are not going to be intumescent. So that's kind of a misconception that we hear at times. There are intumescent paint type products that are used on steel and other elements, but the fire stopping products we're going to talk about today that are sprays and sealants primarily are not intumescent. So you're welcome to check that with your product information, but preformed products like gaskets and other tapes and things like that we'll talk about today, those could be. But these sprays you see here are not going to expand, like a sealant would, an intumescent sealant would in a penetration or a combustible condition. So joints, where are we looking? Hey, don't just look up is the note, right? Any intersection of two rated barriers is a fire resistant joint potentially that has a test standard, a section of code, and a listing. So wall to wall, floor to wall, head of wall, bottom of wall, wall to a fire-proofed or rated column, a lot of different parameters that we could see fire resistant joints. So again, just don't look up is our note there. A lot of terminology to remember here. Again, we're not going to dive into how to read a UL listing, how to do the installation, how to inspect it, but remember, many joints, or almost all joints, I guess we would say, have some kind of movement to them. And that's a parameter that can be quite challenging to properly design. So those the people on the design side, I guess my note here is a growing trend is, hey, I'm doing a data center. The structural engineer on this data center wants to see 3 inches of movement on my building. What? 3 inches? Okay, great. We'll put some elastomeric head of wall spray in there. We do this all the time. This is red stuff I showed a second ago. Good to go. Here's the product information. Well, hold on a second. Time out. Did we read the product information in the listed system to verify it moves 3 inches? And also, structural engineer, what's 3 inches? Is that a ½ inch up, inch and a half up, inch and a half down? Because our slotted track or our framing usually moves in an up and down orientation. Or is that 3 inches down and 3 inches up for 6 inches of movement? So defining the parameters of how much our building moves, 3 inches might be an extreme amount. That's maybe a bad example. But we're seeing a growing trend as an industry for maybe less steel or modular construction or different things that might move more than the older, heavier type of buildings that we've seen or more robust buildings. So I wanted to point out that Verifying that your listed system and products within that can move with the building is a great thing to back up and ask, because it could be more challenging than you think. So in these listed systems and these products, we have joint widths, we have ratings, we have different wall designs, very important, that we're building into. But I want to focus on the standard elastomeric sprays for a second. That red spray we saw, most of those materials, elastomeric sprays and many times sealants, use mineral wool. And if you're not familiar with mineral wool, there's a great video I think the IFC has on their YouTube channel about how mineral wool is made, what it's made of, how it looks. It really tells a great story to watch that. So please take a look for that. But mineral wool is basically, you can see layers of material laid on top of itself and then compressed down with some glue binder to it. Big picture thinking here. So if the material, when properly compressed, itself, mineral comes in different densities. So depending on your density and how you install it, can stop fire, stop flame promulgation. But if it's improperly installed, or there's large amounts of movement, or it's the wrong density, it could fail miserably. So we work together with the proper mineral material and the fire stopping material to help your listed system get you those ratings. So what I'm trying to go with is, if I'm looking at one thing, let me back up in a joint here, I would pick, personally, looking at the mineral wool. Many of us get asked to come out and say, okay, ready to spray, ready to add the caulking. That's your inspection. Let's focus on that, right? And that might be all you do. No offense, that's totally fine. But if I'm doing any area I wanted to pick, I highly recommend we look at the mineral wool to verify it meets the code compliance of the listed system and information that come with that. Because from my experience, that's been the most challenging installation, and the heavy lifter in most of these fire tests. So mineral wool can be cut to different shapes, sizes, like I said, we're seeing here. A lot of times there are some standard parameters that we're gonna follow, but it's not just stuffing material in a hole for fire resistant joints that are dynamic. Penetrations, you might see the same exact mineral wool used, where it's gonna say, hey, throw 2 inches of that mineral wool into the angular space and friction fit it. So there, you might be seeing people take smaller pieces and kind of wedging it, pushing it into the opening as a backing material. Where in a fire resistant joint, it might be the heavy lifter for that elastomeric non-intumescent spray to kind of bond it all together and handle the movement. So we're playing together in a much more crucial role. So where I'm going with that is if you ever want to audit or question or even understand it better, UL in those guides I showed you earlier actually has a way to calculate the mineral compression. So great quiz, great study information to understand what the proper compressions are going to be within the joints. Some math might sound completely simple, and then you put it into this calculation, which is not that challenging. And it comes out a different number than what you're being told or what you assumed. So I highly recommend you take a look at this. It is in the UL guide for fire resistant joints, but to value our uncompressed thickness, it does give us that answer there. So moving ahead of what fire resistant joints elastomeric sprays are, kind of a quick little video if you haven't seen it done before. A lot of times we use a spray rig, pretty heavy duty, assembly to pump out this thicker viscosity elastomeric material. Don't always tape joints off, but commonly we're seeing about a 1/2 inch overspray onto surrounding substrates per the listed system and 2 inches of overspray onto fireproofing or spray applied fireproofing materials. So just something to note, these are one of the few types of materials you'll see the listed system that will actually maybe call out the wet and the dry thickness in the listing, which is quite nice. But overall can handle some quite large installations, vertical, horizontal assemblies. I'm not aware of a listed system with elastomeric firestop joint that does not use mineral wool as its backing material. So if we're seeing it used with, and when I say mineral wool, please clarify your density of mineral. 4-pound density is most commonly used. That's another deficiency we often see. So if I come in the project and all I saw was, let's back up a second, the mineral wool shown here. Hey, look at that. I stuffed it perfectly. Look how it's in there. I'm good to go, right? Look at this one over here. Look how clean this is. I'm ready to spray. How do I know, if I didn't do my storage and handling portion of my inspection, that that was 4-pound density material and that it was compressed at 50% per the listed system or EJ or whatever I have going on in front of me? So again, that's often the challenge. We also see contractors carrying bags of mineral around. They've already cut it. Here it is, pre-cut stuff. Let's go. Well, how do I know what it was? because if we have the wrong density and sometimes the wrong manufacturer is to point out, many listings are specific to a manufacturer's part number of mineral wool. So please, backing up a second is going to help us a lot, because again, I'll say it for a third time, that's our heavy lifter in these listings for fire performance. So I want to make sure we're getting there. So here's a good picture of a destructive test where an inspector pulled out mineral and the elastomeric spray to verify its thickness. Now, the cured thickness is usually about 1/16 of an inch dry, so you might want to have some sort of micrometer or tool to help us digitally verify that. The picture on the left is just kind of showing, ways to measure or kind of thicknesses that might go in that. But on the right, what I wanted to point out was when this was pulled out, the inspector actually saw that the mineral wool was not continuous through the wall, through the listed system. Listed system said full depth of wall. They put in 2 or 3. This looks like a 3-inch block, maybe a 4-inch that was compressed down, and there was a void if you look at the end of that tape there, where there was no mineral wool before we got to the other side. So the inspector wasn't there to witness that. Destructive tests were performed and found that. So the note is, hey, you might want to be there during that installation to randomly witness some of that. The other note as a challenge with mineral wool, to finish my long rant here about the material, is if we have that calculation I showed you for uncompressed mineral wool, that's a way to do it when I'm standing on the ground, someone's cutting it, I can measure it before it goes in the opening. Because what happens after you compress mineral, it has glue binders built into it. So if I'm stepping on it or I put it into a joint at 50%, it most likely is not going to rebound 100% back to its size, or to guarantee that it's exactly in its original shape and size. So it's almost impossible. I know it's up to you to do your due diligence, but we would recommend not taking previously compressed mineral wool and trying to do that calculation. So we recommend, if you want to look at mineral wool, we do it before it's installed, if you're ever doing that calculation. So I think we went through non-intumescent, common overlaps, paintable. So even if you don't like the red color, the yellow, the blue, the gray, whatever, comes in all different shapes and sizes here. But overall, lots of different versatility for this material in dynamic joints. Final statement on that is, if you deal with fluted decking or in your listed system, no matter what kind of condition you have, you might find that listing says, hey, this compression's at 13%, this compression's at 50%. This material can be a pre-manufactured cut material from brand X. This could be brand B, so it's going to give you different tolerances. So I can't, again, assume just put this material at 25% everywhere and call it a day. Each listing is going to be different. So I'm trying to make sure we're not ever coming across like there's a standard rule of thumb for these products in the industry. Elastomeric sealants are going to be the same kind of rules that we just said, but the differences from the sealants that we might see in penetrations, not all, some penetration tests are materials are non-intumescent as well, but these will be materials that don't expand. When they get hot, they don't have graphite or different materials built into them to expand. They might have higher curing percentages or shrinkage values like I showed you earlier. I don't know if you saw the 3M product, but the fire dam material is up to, I think, 40%, something like that. I don't remember the exact number, where the intumescent sealant was about 26%. So elastomeric sealants are designed to be used in fire-resistant joints, pending their listed system, and handle more movement. With that, they're going to cure. They're going to shrink more, and many times they actually create like a concave shape here when they cure. So please note that a rounded shape, once fully cured, is not a negative, because we have ways and recommendations from the IFC to measure at the bond line, which is where it meets the drywall and floor in this case. And we have shrinkage values to calculate that bond line depth once fully cured. So the shrinkage or the concave shape might be engineered by that product to allow it to flex and move in a dynamic joint. So don't let that scare you, I guess what I'm trying to say. And we've shown you some homework to help you understand it shrinks and how much and how to do that. And if you want to know more, again, firestop.org has a training program for that. Common challenges is I do see these materials used probably more than they're supposed to be used, though, is the problem. I can just caulk anything, right? Red is right. Well, I can't. There's a threaded rod right there I'm looking at. Probably can't just fire caulk a threaded rod, hanger right there. Also, I see them used around like joists or trusses or beams, right? Again, show me listed system, and does it meet the movement requirements of my project designed by the structural engineer? Simple question. Great, it does. Here's my listing. Let's go fire caulk, right? Oop, you need to put mineral and frame that out and use a different product. Time out, right? But we want to ask these questions as early as possible. So if I'm able to audit the product data sheets and the listed systems and installation instructions before I start my inspection and installation, hopefully I can do that audit and checks and balances and verify that these products are compliant for the installation we're going to do. Because nobody wants to look like the bad guy when you ask the question after thousands of feet of this has already been installed. You called me out now. You should have called me out a long time ago, right? I think we understand that. So shrinkage value is probably the biggest challenge there. There are also silicone-based sprays and sealants. Couple notes on silicone fire stopping materials. One, all fire stop. Let's just back up and think of all fire stopping for a second. Silicone or not. Fire stopping is not waterproofing. It's not waterproof. So we don't, if we see fire stopping material is used in an area that is exposed to the elements for the life of the building, let's raise our hand, red flag. Not the way we're designing it, hasn't been tested for that. We don't know what's going to happen, warranty issues, all that kind of stuff. Waterproofing, obviously a very important item, right? We are faced at times with fire resistant joints and penetrations in exterior assemblies. And that's a good time to take that time out and make sure we have the proper documentation to show how those materials are going to be covered, concealed, and waterproofed, not with the fire stop. But fire stopping materials as an industry, many of them, like we talked about already and we're going to talk about later, are water resistant once fully cured. So that's where the product data sheet's really going to help us. Checking that to verify how long does it take to cure again? And when can it be touched with some sort of moisture? And how much moisture is acceptable for how long? Things like that we want to understand, right? This should be used once fully cured in temporary weather conditions. Now, a silicone-based material might either cure faster, skin over faster, or handle moisture faster. Or it might be more flexible and do a better job with cleaning or different constructability issues that we see on a project. So we do see projects try to use silicone. We also hear terms like W ratings thrown out, that this product or listing has a W rating. Again, I want to point out that the products, even silicone, have a cure time. So I have seen projects where they went to a product like this and assumed it was, handles all kinds of water. And they did all this fire stopping on a Friday, it rained Friday night or Saturday morning, and they came back on Monday and there was water running down the building and say, hey, what the heck? We used all this stuff that was silicone and it still got water through these joints and penetrations. And the response was the cure time, it got wet before it was fully cured. So products still have to cure, give them a second, right? With these types of materials. So don't assume, again, let's do the homework and make sure that we're there. But again, listed systems that can be used with silicone-based caulkings, self-leveling sealants, like you're seeing on the screen there in a horizontal joint, and actually sprays. Many of these self-leveling and spray materials are more for horizontal joints, like perimeter fire containment, slab edges, and the sealants or gun grade might be more for penetrations or vertical joints. So again, we have to check the listings. Now, preform products. This is an industry that's been around for a very long time. You might not have seen them as much, but been around for a while and continues to evolve. And the idea behind this, just like with the penetration products we'll talk about today, is there a factory meter dose? So the idea of, well, Brent, that mineral calculation just blew my mind. I don't want to deal with that. Well, maybe there's a product that can help us with that reduce that challenge, right? Or, oh, my project has lots and lots of movement. You're making a point here that my fire caulk might crack as the building moves up and down, right? Is there a material that might get 100% movement or more movement than that fire caulking? Sure, maybe something like this that doesn't use a sealant or a mineral backing that might dislodge or loosen or crack. So there are advantages with these types of products in different areas. So, but the overall message we want to make sure we started the day with is even if it's a preformed product and manufacturer dose, the product does not hold a rating. I still have all the same paperwork, procedures, inspections, and installation instructions that I had with all these other materials. We're all in the same boat. So don't assume that these materials, once installed, are covering all ratings and can be used in all different types of walls because they have their own limitations, just like everything else. So hope I'm not too negative with that. It's just making sure we're not overlooking the basics, right? So there are products with intumescent gaskets that expand on foam. There are vinyl gaskets. There are intumescent or foam items that go over tracks. There are elements that go in front of the drywall after the drywall is installed. So each product has its own competitive advantage. I will note at the end of the class, there is IFC has a product training area that you can sign up for that goes through many of these in much more detail. So there is a QR code at the end of this class. If you'd like to learn more about each of these materials or all the materials we're talking about today, please take a look at firestop.org for that product training or the QR code at the end of the class. What I want to point out here is, we were talking about movement for a second. What I like to say, why I just said the products don't hold a rating, the listings are all different. This is a screenshot of a listing of a preformed product, which gets up to 100% compression or extension, moves 100% up and down because the joint has nothing in it where that slotted track goes up and down. Completely empty because the fire stops on the outside of the wall, allows it to freely move. But if you read right here, it's a 1-inch joint with this product, I get 100% up and down movement. But at a 2-inch joint, I get 100% downward movement and 0 upward movement. So how we frame the wall, how we use the slotted track, how we cut the drywall and install it, and which product we select still has a variable on how big of a joint and movement I could have, just big picture thinking. So I'm trying to say, don't assume I always get 100% movement with the material. You may, if you're following the guidelines in the listing per the parameters of the product. Other times you might be well below what's needed there. So what to watch out for? Hey, I'm giving you some ideas to think about, but also this actually goes with all fire resistant joints, but how are we playing with MEPs, right? This photo, if you could assume after drywall goes up here, I can stick my fingers up into this cast in place fire stop device, as you see here. So what I wanted to think about is MEPs sometimes definitely, we all play again in the same pool, but we want to make sure we're working together. Might get in the way and notch my top track where this intumescent material is going that needs backing, or it overlaps and now when I put in my drywall, there is no mineral wool or fire stop closing this area off. So what happens with this void right here? So the recommendation, just like with drywall, who cuts the holes is a great question to remember to ask. Are you reading the fire stopping listing to understand annular spaces? How we're laying out our pipes is also going to be an important process, especially with these materials, because my pipe might fit here, but what's going on the outside of that rated wall once the drywall is installed? So not just with these preformed products, but just something to think about that many times top track is notched on the top or bottom track to allow an MEP to sneak by. Do I have paperwork that allows that with the joints, with the penetrations, and we're all playing together to verify the fire stops work here? Another note, many of these preformed materials may require mineral wool inside of a stud cavity with primarily shaft wall construction. So we haven't talked much about shafts. It's a growing trend that we see where shaft wall construction is used outside of just shafts. So we see it just to skinny up past the column or save some space in a room or a stairwell, things like that. Where we're building the wall from one side, even though it's not a shaft per definition, like a mechanical shaft behind that. Shaft wall construction is a growing trend in use. So remember, there are listed systems for penetrations and joints that specifically show the shaft wall, just like the wall design has its own listed system for shaft wall. In that, you might find additional materials are required in the shaft wall. So let's keep a lookout for that. Want to make sure we don't come out too late and this item might be closed up and then we're putting materials on later. So can be advantageous materials, comes in all different shapes and sizes. I think we're understanding the message of please still read your listed system to verify its compliance and the exact barrier we're working with. Tapes, there are actually, speaking of cure time, preformed materials and tape here, I got 0 cure time, going back to that statement a second ago, so there's a positive, right? But now there are tape applied materials. Non-intumescent is the note here, and comes in different widths that might have certain overlaps, and installation instructions are probably pretty key with this type of material, but that can be used in fire resistant joints. What I want to note here is mineral wool, again, big heavy lifter here, because the tape's not intumescent in this potential product. It's not doing anything super fancy as far as fire performance, but it's going to help us on a lightweight material that we can maybe throw down quickly with 0 cure time, but the mineral wool is going to be our focus that we're looking at. Be careful, kind of a note, this picture is showing smoke and sound tape. It's actually a good question. Many fire stopping materials or manufacturers make an acoustical or non-rated product as well. Many of them also make fire blocking and draft stopping materials. So just because the name of the manufacturer sounds like, oh, Firestop, I always use them for fire caulking, Doesn't mean they don't have products for non-rated assemblies or non-rated conditions. And we want to make sure we don't get those mixed up, right? That's kind of the point. So you'll see on this tape product here, the ASTM standard that it was tested for is right on the tape. So remember, circling back to those UL listings or those Intertech listings, they actually list the test standard right on them. That's a simple step to make sure per code we're following the right test standard per our listed system we're inspecting to, and the material was tested in accordance with that product, that test standard. Perimeter fire containment. Very challenging topic. There's a whole training on just this for a whole day. But the challenge of it, I want to make sure people know, is we're now dealing with a rated floor and products installed from that rated floor to a non-rated facade. And we're trying to stop fire from the inside, floor to floor. So from the floor inside the building upward. But I just said non-rated facade. So if my glass breaks, my aluminum melts out, or the whole panel falls off the freaking building, right? How am I supposed to stop fire? It's a non-rated facade. So that's going to be our big picture thought process. If you want to take something home, is many of us are asked to focus on, here comes the spray, time to do our inspection. But I'm trying to tell you, if the panel falls off the building or the materials in the panel don't perform, who cares about the spray? Who cares about any of this? Isn't it all going to fall out in an event of a fire? So maybe backing up a second and making sure I understand the facade, its construction, and the materials that are going in that facade to help me do my mineral wool and spray in the joint would be a good area of focus. And the challenge is many of us might not have the ability or time or given the time to do that as an inspector. So just something maybe to add to your list. But again, we're trying to bring the rating out to the non-rated exterior and stop fire vertically floor to floor inside the building. So fun photo. If you've never seen a test, here's actually after a fire test of ASTM E2307 per the code. And you can see here, this is outside of the glass building, similar to the photo we were looking like from the inside of the building. Large amount of glass broken up here on the underside of the floor. Even glass above the floor broke. It doesn't always happen, but sometimes it does. And take a look here if you can see, there's vertical aluminum mullions and horizontal aluminum transoms. But the aluminum mullion actually melted right here, gone, 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 till about right here. And then that's that insulation, that foil-faced insulation we just showed in that photo previously. It's still there. But you can see how much melting went almost all the way up to that transom at the floor above. And the glass is breaking. So I'm trying to prove a point during this test. If this melts out or falls out, so does my Firestop and my pretty Firestop spray or material that I compressed or formed into there. So don't overlook the parameters of the facade, because when we do this test, we have a fire under the floor and a second burner outside the building to simulate fire hitting it from both sides, because it's a non-rated barrier. Fire's gonna get out the building. Fire's gonna work itself out. And what happens when it works itself out? The challenge is you don't fail if fire leapfrogs through the window here and I can see it up here. You only fail when it comes through the vertical joint per the E2307 standard. There's a lot more to that statement, but big picture thinking, there's different test standards, different sections of code, different ways to evaluate that. Our main focus is the inside flame promulgation travel. So understanding the terminology, please do some more research on this. Take a look at the reading literature the IFC has on this topic, but understanding mullions and transoms and spacing and spandrel panels, what the facade is made out of. Is it aluminum? Do I have a shadow box or a back pan? How tall is my transom off the floor? How's my facade attached to the floor? What's going to hold it there? How do I fire stop around that? All these types of questions. And why I'm saying let's look beyond the spray, many of these listed systems require mechanical fastening a certain parameter with maybe stiffeners or supports for mineral wool insulation or other products to be mechanically fastened or clipped into these assemblies. So if I show up on a job and my insulation is already installed like this, how do I know? Yeah, I see a pin there, but how do I know it was the right attachment, how that was attached, and how all this worked together? And the challenge with these products are these systems, many times they're unitized, they're done off site, they're flown in from a different country. So as an inspector or an AHJ, definitely hopefully taking a back step, stepping back up and asking that question, how are we doing this? Where are we doing it? And can you prove to me that we're following the same listed system for these components as well as these components that we're seeing in the field, or mullion cover is also seen here to cover it up. So I've been on jobs where I've seen this inspected by one company overseas, and then this installed by a different company inspected on a project in the States, and they were both looking at two different documents. And the AHJ is like, what is going on here? How do we have it inspected by two different companies, installed by two different companies, and you're both looking at two non-approved documents by me? So let's back up and think about that before we get too far ahead on our project. Mullion covers, sometimes we have to finish and put additional insulation mineral wool over these aluminum products because I showed you they melt out many times. Not all listings require that, but a good thing to remember that sometimes it can be challenging to install with surrounding construction tolerances. So I hope it makes sense that perimeter fire containment and the mineral wool that goes into the joint. Real quick note, this mineral wool in our safing slot is often 4 PCF material. This mineral wool on the facade that is pinned or mechanically fastened is usually 8 PCF mineral, so heavier density foil phase. So it might be the same manufacturer. Please check your listed system to make sure the manufacturer that was done here is in that listing. These are notorious for specifically calling out manufacturers of products of mineral wool. So I don't see any labeling on this. Red flag. What's going on here? Is that the product that is on my listed system? This one has labeling right there. I can check that, right? So as we finish up on perimeter fire containment, I want to make sure everyone's aware that there's tons of different facades. Again, it's a full day class of training. So hopefully you can understand there's different parameters. Let's ask questions to understand how that facade is built. Let's make sure that facade and how it attaches and how it comes together and the materials in it all match my fire stopping listing. And we don't just come in looking at spray time. Let's take a look at that, because that could be the most minor part of the overall assembly. So metal stud framing also, again, showing the example there, we might have to work around that to the exterior sheathing. But picture shows, don't forget, what do we do at a king stud? I can't get in there. What do I do there? Just wedge some caulking in there and call it a day? What about transitions over here? Like what happens when we transition to a different facade? That's why I'm showing this picture. If you back up a second, what happens when we go from a stick-built curtain wall to a concrete panel? How do we deal with those joints? So trying to think beyond just the spray is our note, that most architects make very pretty buildings and they might zigzag in and out and have all different types of facades, but that could be multiple fire stopping inspection documents and installation documents. Attachment brackets we also talked about. Many times they get in our way to do our fire stopping and the components we talked about. So question I always like to ask is our listing accommodate that, and talk about that, and how do I install materials around those elements, because they're going to be there. Many of those listed systems we have talked about use mineral wool and elastomeric sprays or silicone sprays. There are also preformed products for perimeter fire containment. Some of those materials are foam-based materials. Some might be slightly intumescent. Some might be more mineral-based materials that could even be pre-cut to different areas. So what I'd like to point out is we're seeing, again, a trend of let's reduce the mineral compression challenges you keep talking about, Brent, or let's make a product that might hold better into a larger void, because we're seeing joints get bigger and bigger, or be more preformed to work around some of these elements you're talking about. But again, these preformed products still have the same paperwork, same code compliance, same installation challenges that the ones we were talking about earlier have. So don't assume the product is rated, is our theme of the day. So intumescent sealant, as we hit the home stretch, there's lots and lots of products. In an hour, we don't have time to cover the entire fire stopping world, but we're going to do our best. I hope to hit home on the joints like we talked about, and products and terminology, just the most common items we're seeing out there today. So hopefully there's some questions as I finish up with some common product challenges, and yeah, we'll keep on going. So intumescent sealants, or let's say non-intumescent sealants, let's bundle them together for a second. They can be used in penetrations. You actually might be surprised that non-intumescent fire stopping sealants might have testing on some combustible items, surprisingly. So you don't assume. We want to read the fine print of the listed system. What I see in the picture here, some common challenges to not overlook. The installation on the bottom of the screen was actually signed off by an inspector. It looked great at the time of installation. They got below the pipe clamp. Firestop was installed. It was clean. They did the right depths, things like that. But over time, as it cured, two things happened here potentially. One, it shrank, we know that, which is allowed. Two, lots of debris there. Look at all the debris that came in probably after, but did we prep the substrate ahead of the installation? Did we get rid of all the drywall debris or fireproofing or whatever loose materials were on that ground before we installed fire stopping, even within the angular space and on the pipe? It's crucial because we see it every job. Fire stop cracks. It happens because it shrinks, right? That's what we keep saying. So how we prep that substrate is going to make a huge difference. Check your product data sheet, talk to your manufacturer. I don't think it's going to be an overkill process, but it's going to help us greatly have better adhesion and less damage like this after our inspection. The reason I point this out is if I'm doing visual inspection, I take a picture of it, I signed off on it, slam dunk, this guy, girl killed it, we followed the listing, great inspection. AHJ comes in a month later, look for wall close-up, sees all these cracks right here and calls me up and said, yo, what's going on? Why is you signed off on all this? Look how it's damaged everywhere. Well, as in a visual inspection, I only witnessed it at the time of the installation. I didn't come back later. I'm not hired to do that, right? So these are the challenges we might see as an industry over that cure time. Number two, pipe clamps. I think we've all seen them before. We always recommend to get them out of the way because the Firestop listing does not talk about that usually. So we're looking for a depth of material all the way from the pipe to the wall, not the pipe clamp to the wall. So how do we verify? I see caulking right here, right? Did they get caulking under that pipe clamp? Was I there to witness that? I don't know. It doesn't look like they raised it up now. I'm changing my tune on this installation. And we might want to perform a destructive examination to see was Firestop all the way to the pipe, because that's what the listing says. So pipe clamps, common problem, all different types of them out there. Wood frame have those like isolators that pop into the wood. That's even bigger or challenging to think about that. You got to think about what the code allows for these types of penetrations, how they're rigidly supported. Didn't cover that today, but your Firestop listing does say penetration or pipe or cable rigidly supported on both sides of the barrier. So that means the UL actually has, in those documents I told you and others, their definition of what they like to see. And rigidly supported, obviously we need to meet our building code requirements for the plumbing, electrical, mechanical, whatever the piping local requirements are to support that pipe, right? Number two, the Firestop provides no support. So I want to make sure that if I pulled the fire caulk out of that wall penetration or that floor penetration, that cable or penetration does not move because it was resting on my Firestop, right? So hopefully that makes sense. There are documents, like I said, that help clarify that further from the testing laboratories. The other picture here is on the top. Well, it could look great on the outside, but in the back, I'm not seeing 5/8 depth. And that's the reality of Firestop. It is challenging. That's why we tool it, right? We're assessing the material in the opening, but real world is we don't get to look at the back of the opening. So I'm somebody, if I had to pick one, I like to do visual inspection because I can look at all the pieces of the recipe, a whole listed system from step A to Z, right? I can stop in the middle of the installation and say, just caulk the bottom half of that opening and let's look at the angular space and the Firestop depth before you close it up, right? Those kind of things that can be done. But if you're not comfortable with that, you can, as a team, the project can select destructive examination. And I could dig this out and do those measurements. Again, whole separate training. But I just want to point out the reality of this can happen. It could look great on the outside, look great on the outside, and have all kinds of problems on the inside. Shelf life. Let's not forget that. Storage and handling materials, fire stopping materials, many of them have shelf life as short as maybe 6 months, maybe as long as a couple years. Most materials have a batch code on them or a Julian date or a stamp or something in the product data sheet. Usually tells you how to read that, or there's a separate document that will tell you when it was either manufactured or when it expires. So please remember that fire stopping materials have a shelf life. Before we install them or inspect them, let's randomly sample and make sure that those materials, before they're opened, are still within compliance of that shelf life of the manufacturer. So we are still seeing, like I said, damaged material, nice, clean, prepped, labeled, all kinds of stuff going on there. It looks good, but materials and damages do occur. A lot of times we see people fire stop. I'll see fire stopping over a metal stud. So right there, that's me knowing that they didn't fire caulk to the drywall prior to the stud attachment. Did we get in all the way around the angular space on all sides? I'm going to question right here, why is there so much fire caulk on that metal stud, right? So coordination and timeline of when we do what is very important. And then finally, again, how we cut the holes, who cuts the holes, Who's cutting the floor openings and sleeves and the framing? Are we all coordinating together? Pipe supports, think about that. Does the listing talk about calcium silicate shields in the wall, or is that supposed to be out of the wall? So there's days and days of photos like this. I'm going to stop here just because we are at time and zoom ahead to the end of the presentation to make sure you guys have a QR code if you'd like further education on the materials we did not cover today. I apologize, as you're seeing, we didn't get through a lot. Here is a QR code and a link to take a look at firestop.org, where there is numerous trainings available to you, including product training, since we did not get through all products today. You definitely can attend these classes and other webinars the IFC has at firestop.org or training.firestop.org. I apologize. You even have free trainings if you're an AHJ. You want the IFC to come to you? Not a problem. They do it for free. I'm actually doing a presentation this Friday for a jurisdiction. So email info@firestop.org and the IFC will come to you and perform a 2, 4, or an 8-hour class. And then if you need contact information or help, the IFC would love to talk to you, help you out, and answer any questions. Here's their contact information. Firestop.org is the website. It's probably how you found us. You probably already have their contact information. So at least looks like my screen's lagging a little bit. I apologize, just trying to finish through here. And then finally, the IFC is made up of many members, manufacturers, testing labs, consultants, inspectors. It meets twice a year. So always looking for new people to join the industry or the association and have a voice. What's always nice about these meetings is you can learn a lot and you can have a say. It's not thousands of people in a gigantic hall. The industry is a smaller group that is made up of now in this group, all passive fire protection, expansion joints, fireproofing. We see mineral wool, we see fire wrap, Firestop, different types of products, all getting in the room together and working to improve the industry and a continued effort. So we'd always love more people as a member of the IFC and take a look and learn more at firestop.org. So I'll stop there. Appreciate everyone's time and hopefully an informative webinar, and happy to look at questions or circle back on that in the future, Aaron.
All right, thank you, Brent, for sharing and for this webinar. It's very informative. We do have a couple questions I'll throw out to you. So one question was, what is the normal time frame for curing?
Great question. As I told you, the shrinkage values are all in a controlled environment. My politically correct response is please contact your manufacturer and check your product data sheets. You will find some will give you clear answers, some you might need to search for it a little bit. So I think I've seen product data sheets that will say this product cures 1/8 of an inch a day on average. So most fire stopping sealants and caulks, things like that, take a lot longer than you think. So 1/8 of an inch a day, let's just do the math if you're doing an inch of fire caulk, right? So just think about more could be even more challenging on cure time. What I didn't note was, please check your manufacturer, but usually you can't paint over a fire stopping material until it's fully cured. So if it's a week or two to fully cure, because water is evaporating out of it, you don't want to install paint because it will crack the paint, right? So something to think about if you have to paint over these materials, please consult your manufacturer. But typical sealants could take a week or two, let's say. Spray applied materials might be faster because they're coming on thinner. I've seen some information about, let's say, 24 hours or 48 hours. So the product data sheet's going to be your friend on that one, though.
All right, thank you. I'll get you a few more came in. What is the solution when the Firestop caulk cracks?
Another great question we didn't cover. I thank you for that. A couple of different answers. Consult your manufacturer. The product data sheet usually will give repair instructions. So sometimes it will say, I've read some, let's say, it will say, remove the damaged area and then reapply the material per the listed system. The note there, and then it might even say overlap new and old material X distance. The challenge I didn't really note, I should have earlier, is that not all products are auto bonding to themselves. So just smearing a thin layer of new material over the crack that I showed in that picture, how do you know you're getting 5/8 depth back into that cracked area, right? Or is the material even auto bonding to itself, which is wet to dry? So the best solution that we would recommend, consult your manufacturer, check their guidelines, but most likely removing the damaged material, reapplying it per the listed system, and verifying it was auto bonding if there's any overlaps to that. When it cracked like the photo I showed you, we usually just pull it. It's almost all the way around the pipe, right? So let's just start over for verification. But every manufacturer is different. They might say different and say, Brent, just put a skim coat over it. I can't speak for them.
All right, thank you. Let me see if I can decipher this one and send it over to you, Brent. When reviewing joint widths and dynamic walls, framing details reference stud recess from the floor. Does the gypsum need to follow this recess to achieve a continuous joint width?
I think I understand the question. I don't know if I can draw on the screen or not. So a lot of times you have a top track and then you have a stud built into that. And that stud is recessed, let's say 3/4 of an inch. I don't know if you guys can see my screen. And then the drywall comes in. Maybe the question is, do I also need to put my drywall in at that same exact joint size or different? I think is the question. And my note is engineering drawings of the framing often don't factor in that Firestop's going to move differently. They're looking at the stud is going to go up 3/4 and down 3/4, right? It moves freely, but the Firestop might not move 100%. So you might find yourself needing to have a much larger gap to accommodate the movement of that Firestop. Why that's important is many times you might need a deeper leg track now to accommodate the drywall being at a bigger gap than how the stud was applied. It might be confusing to some, but what I'm trying to say is the stud moves freely, Firestop might only move 25% or 50%, so I need to double, triple, quadruple my gap from the drywall to that deck. That was kind of the challenge I was pointing out that I think the person's asking or saying is we all need to align, and sometimes to get that movement, a longer slotted track or nested track or leg of the top track has to be engineered and installed, which is might be a big ask, right? That's not simple sometimes.
All right, thank you. Next question is, you mentioned destructive testing. What can you speak to on patching materials following the destructive test or inspection?
Patching, is that what you said?
That's correct.
I'd
I
have
think
to
the question is,
recommend,
how do you,
yeah,
oh,
go
go
ahead.
ahead.
The repair procedure is kind of what I said before. It's going to be the same challenge. If I perform a destructive examination, I'm taking out coupons, and I noted that firestop.org has a procedure the IFC recommends. Please take a look at that. We didn't get into that procedure today, I guess, to the question asker, that there are documents on the website that will go through how to, how many coupons, where to measure, how much we're taking out, all those parameters. So please look at that document. We then need to fill those back in. So that goes back to the same question we just said. If I'm doing destructive sampling, I recommend before we start, we have a repair procedure from the manufacturer of how to do that. Do I need to take all the Firestop out again? Or if it was destructively examined, I measured it, it was in compliance, shrinkage values, things like that, right? And I'm good. Can I just add more sealant back into the opening or the joint and call it a day? Usually, yes, if you have that repair procedure from the manufacturer handy and you have the listed system to verify the new materials went back into it. So there are some question marks there, I guess I would say. I don't want to dictate what the manufacturer is going to require, but often, if done properly, you could take the coupon out, let's say, and then refill it per listed system without damaging more of the overall angular space or joint. A lot of that goes into the tools, right, Aaron? So that's a whole nother training. I don't know when your IFC might be putting one of those on, but the techniques and tools, right, we use to do that destructive examination play a big part to get that clean.
Absolutely. We have a few coming. I'm going to ask you one last question, and we're going to close. And if we didn't get to your question, or you think of another question, you can feel free to email that to us at info@firestop.org, and we will get that over to Brent, or we'll have that answered for you. So the last question here that we want to ask that came in is, the question is it compliant if a joint is dynamic and has a CPVC sprinkler pipe through the head of wall joint?
Didn't cover penetrations through dynamic joints. Good question. That's kind of a clash we often see. Just penetrations in general, vertically or horizontally. Think about they're going to notch that top track I was just drawing. And the short answer is maybe, unfortunately, right? So if I have my top track, and let's just draw a drywall in for a second, excuse my poor drawing. And then the pipe comes through, it's usually like right at the deck, right? Let's say it comes through it might be right at the deck, or it might be below the deck, but it's notching at my fire stop and my drywall, or even just my top track. Anything touching that top track or notching the top track could be a problem. So if an elevation view, I have like a slotted top track, have you ever seen it? And then I come in and I cut this piece out right here to allow my pipe. Did the engineer of that framing sign off on allowing that? And do we have proof that it's going to move as originally designed? I know the fire stopping has some ways to prove that, but the engineering of the framing also needs to be questioned. So we usually recommend a no-fly zone as a consultant, to keep that pipe down a certain distance from that top track. So it's down here, whatever that measurement is, each job's a little differently. We call it no-fly zone because we want to stay away from that question. But if it does occur, my short answer is there are a few listed systems I'm aware of on the UL directory that do talk about penetrations through dynamic joints, even maybe with CPVC, a small penetration, through those joints. But the challenge is very limited, don't know about the movements, very small penetrations, and probably does not accommodate all your head of wall joints. Think of a building. Flat slabs, one thing, but non-flat concrete post-tension slabs could have a lot of different variables. So I don't know if I answered the question perfectly. I recommend staying away from it. If you do see it, I usually flag it and say, show me a listed system that maintains the rating and the project's movement that allow this penetration in it. Because usually now the plumber, let's say, is playing in the drywaller's pool. Who fire stops it? Are we using the same products, the same system, EJ, engineering judgment? What approved document are we using? So it muddies the waters, let's say. But there are a few listings out there. Please contact your manufacturer, but very few.
All right, excellent. Well, that will conclude our webinar today. Thank you, Brent, for sharing and for being on and teaching us and answering our questions. We appreciate that. If anybody else has any questions or comments, anything they'd like to know or ask, feel free to email us at info@firestop.org, and we'll respond to you. Thank you all very much for logging on, and we'll see you on the next one.
Thank you.